Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 56 in chapter 32. Chapter 32 is about light, reflection, refraction. There we have a visible light, right? We know the light travels from the air to the glass. For the glass, the refraction index is given as n. And also, we know the delta n is around 1%. Now we need to consider the incident angle as theta 1. Ask you what is delta theta 2, and the delta theta 2 should equal in this equation. Ask you to prove it, and also give you the hint there. So for this case, we can see we know the incident wave in the air, so n1 is given, and we know the incident angle theta 1, and we know the refraction wave as n and sine theta 2, right? This is the Snell equation. We can write it. From this equation, we can write down the equation about the theta 2, this angle. And now we can see the theta 2 is a sine, arc sine, and then inside this one. And now you can see what we want to know is delta theta 2 equals in this equation. You can see in this equation you have another one called delta n, right? Things becomes very straightforward. See, we have delta theta 2 there and delta n. Our strategy is move this delta n in the left hand side. So in this case, what if we know delta theta 2 divided by delta n equals the left terms? So this is our strategies. So now we can see delta theta 2 over delta n. We can see it very just approximately equal to d theta 2 with dc, right? Differential the theta 2 with dn. Now we can look back. From this equation about theta 2, we can see we input given quantities. n1 is 1, so we put it there. We know theta 1 is given, n is unknown. We can consider this is the equation, right? The equation about theta 2 is just with one unknown quantities, n. Right, as a function. Now we can see, can you do calculation for the differential theta 2 with n? Yes, give you the hint there, very straightforward. We can consider the whole part in this bracket as x. So it becomes sine, arc sine x, right? So now you can write it as 1 over squared 1 minus x squared. So this is x. And now we look inside this term, and we still need to do the differential theta 2 with n, right? So we still need to do n. And we can say sine theta 1 is as a constant. So we do it again. And then we have the negative, the n squared there. So this is how we do the differential. Now we can simplify it. After we simplify it, you can see it looks like this one. And compare with what is given. Yeah, exactly it equals to this equation. So we proved, right? Yes. At part B, we know we proved this equation at there. And we know n is 1.5 and the delta n is 1%, that is 0.01. In case B, tell us theta 1 equal to 0. Can you find theta 2? Yes. So in this case, you can see delta n is given, n is given, sine theta 1 is given, theta 1 is given, so it equal to 0. Because theta 1 equal to 0, so we look at this sine theta 1, 0. Don't need much calculations. Now, if theta 1 equal to 90 degrees, similarly, this one is given, n is given, theta 1 is given, theta 1 is given. Input all the quantities, you can get answer there. Thank you.